Good morning, grade 11. Now, inshallah, we are going to complete the part 2 in solution concentration. And we must take in consideration that this is a ninth week and ninth week value, which is time investment, and how can we benefit from our time, okay, and don't waste any minute, okay. We are going to complete, we studied before at part 1 solution concentration, and we studied the meaning of solution, and we solved some problems about solution concentration. Okay, now we are going to complete molarity, difference between molarity and molality. Okay, listen please. In this problem, okay, if you know the concentration and the volume of the solution you want to prepare, you can calculate the volume of stock solution. You will need what? Volume in milliliters, of 2 mole calcium chloride, CaCl2 stock. Solution would you use to make 0.50 liter of 0.3 mole calcium chloride solution. Okay, first you are given the molarity of stock of solution of CaCl2, molarity of CaCl2, okay, and the volume and molarity of a dilute solution of CaCl2. Use the relationship between molarities and volume to find the volume in liter of stock solution required. Then convert the volume to milliliter. Okay. Now first M1 molarity, okay, of CaCl2, which is what? CaCl2, which is 2 moles. Okay, and the M2, okay, of molarity equal what? Equal 3 of calcium chloride also equals 3 moles. So M1 equal 2, M2 equal 0.3. V2, okay, solution would you use to make 0.50 liter of calcium chloride. So it's V2 related to M2, V2 0.50. Okay, so the unknown part is V1, okay, milli. V1, what is the milli of 2 moles of CaCl2? Called milliliter, okay, because he wants this by milliliter. Solve the molarity volume relationship for the volume of the stock solution V1. Add direction bound points as desired. State the rule first. M1 V1 equal M2 V2. It's a rule, okay? After that, so V1 equal what? V1 equal M2 V2 over M1. Okay, M2 V2 over M1. Okay, is V1 M2 V2 over M1. Okay, so after that, substitute M1 first. M1 equal to mole, M2 3 mole, V2 0.5. So by calculating this equation, we are going to get that V1 equal what? V1 equal 75 milliliter. It's very easy by the problem. Okay, 75 milliliter. To make the dilution, measure out 75 milli of the stock solution and dilute it with enough water to make the final volume 0.50 liter. Okay, the volume V1 was calculated and then its value was converted to milliliter. Okay, this volume should be less than the final volume of the dilute solution, and it's of the given information V2 have the fewest number of significant figures with 2. Thus, the volume V1 should also have 2 significant figures, and it does. Okay, this is a problem. Okay, there's no problem. This is a molarity. So we studied solution concentration and molarity. Now we are going to study molality. What's meant by molality? It's okay. Molality. Listen, please.
Expressing concentration. Molality is the ratio of moles of solute dissolved in 1 kilogram of solvent.
So molality depends on the mass, but molarity depends on what? Depends on volume. Okay, molarity depends on what? yes, volume, but molality in mass. Okay, so molality. So he said that is the ratio of moles of solute dissolved in 1 kilogram of solvent. So molality, its rule is moles of solute over kilogram of solvent. Okay. After that, how can we answer this problem? In the lab, students add 4.5 gram of sodium chloride NaCl to 100 gram of water. Calculate the molality of the solution. Molality. So first, the known and unknown. We must determine the known parts and unknown. So we must write the rules that we are going to study by it. Okay. After that, you are given the mass of solute and solvent. Determine the number of moles of solute. Then you can calculate the molality. Number of moles. Who can answer me what is the rule of number of moles? How can we get number of moles of any substance? Yes? Good. Number of moles equal mass of substance divided by molar mass. Mass of substance divided by molar mass, as we studied before in the previous example at the last session. Okay, after that, the known mass of water is what? Is 100 gram. It's a solvent. Mass of sodium chloride solute NaCl is 4.5 gram. Okay, unknown is the mass. Okay, calculate the number of moles first. Number of moles equal what? Equal mass of substance divided by molar mass. Okay, mass of substance of NaCl equal 4.5. We have a molar mass for 58. Molar mass, okay, of sodium chloride, as we said before, to get we make a revision before. Okay. Molar mass equal what? Molar mass of NaCl equal what? NaCl equal molar mass. Na equal 23 plus Cl equal 35.5. Okay, it's atomic mass of each one. So 23 plus 35.5 equal what? Equal 58.5 gram. It's a molar mass of sodium chloride. Okay, you must calculate it before solving this problem. Molar mass of NaCl. Okay, after that, so 58, 4.5 mass of substance divided by 58.4 of NaCl equals 0.077 mole NaCl. So it's the number of moles, okay, that we calculated. Number of moles, mass of substance divided by molar mass. So 0.077 is the number of moles. Convert the mass of H2O from grams to kilogram. You must solve it by gram, not kilogram. You think this 100 gram divided by 1000 to change it into grams. 100 divided by 1000 equal what? Equal 0.1 kilogram. Okay, to change it from gram to kilogram. Okay, convert the mass of H2O from gram to kilogram using factor. From gram to kilogram, because we depend on solving this problem as the mass of substance is 1 kilogram, not gram. Okay, so 100 gram equals 0.1 kilogram as we calculated it. After that, substitute the known value into the expression for molality and solve. Molality equal what? Moles of solute divided by kilogram of solvent. Mole of solute that we calculated 0.077 divided by the kilogram of solvent that we studied and we say we calculated. So it equals 0.1 kilogram. Equal finally 0.77 mole per kilogram. And this is a measuring unit of molality. Mole per kilogram. It's okay? Because there was less than 1/10 of a mole of solute present in 1/10 of a kilogram of water, the molality should be less than 1, and it's the mass of sodium chloride was given with 2 scientific figures. Therefore, the molality is also expressed with 2 scientific figures. It's okay? Understand? After that, mole fraction, the last part, it's meant by mole fraction. Okay, listen please.
Expressing concentration. Mole fraction is the ratio of the number of moles of solute in solution to the total number of moles of solute and solvent.
So, mole fraction is the ratio of the number of moles of solute in solution to the total of moles of solute and solvent. Okay? So, XA and XP, the mole fraction of each substance. XA equal Na plus Na plus Nb. XP equal Nb divided by Na plus Nb. So, what's the difference? If it's XA, so it's Na at the top. If it was XP, so Nb at the top. But Na plus Nb, it's constant. Okay, so Na or Nb, okay, determine that XA or XP, depend on it. If XA, so Na over Na plus Nb. If XP, so Nb divided by Na plus Nb. Okay. After that, percentage by moles equal what is percentage by moles? It's hydrochloric acid in aqueous solution. Hydrochloric acid HCl. HCl in aqueous solution, so it would have water. So, water H2O by percentage 78%, while HCl by percentage is 22%. So, HCl plus XHCl plus H2O must equal 1 because the percentage of solution must be 100%. So, 0.22 plus 0.78 equal 1. That equals 100%. It's called the percent by mole. It's okay. After that, so we ended the lesson. Review essential questions that we studied. Lesson, please.
Expressing concentration. Mole fraction is the ratio of the number of moles of solute in solution to the total number of moles of solute and solvent.
Okay. So, in the vocabs that we studied, concentration, molarity, okay, molality, mole fraction, and this is the end of this lesson. Okay. Now we are going to solve some question of the lesson from what? From the macro health. Okay. Lesson, please. Okay. Number 1. What is the percent by mass of NaCl in a solution contains 17.5 gram NaCl per 500 gram of water. Okay, so we are going to solve these problems. Okay, the percentage of mass. First, we must get molar mass of NaCl, which equals 58.4 that we calculated it before. Okay, that is the mass of NaCl divided by the mass of water. Okay, and we are going to calculate it. Okay, to be, I think that after calculating it. Molarity defined as what? What's meant by molarity? Yes, molarity. Good. Molarity depends on volume, so it's moles of solute per liter of solution. Okay, equal what? Equal mole per mole of solute per liter of solution. What is the mole fraction C2H5 OH in solution? Okay, you must calculate it. What is the molarity of HCl in aqueous solution, which is fractions HCl? Okay, so the molarity HCl, okay, and H2O per 100. So this is the amount. Okay, you can calculate it. Okay. What is the molality of HCl in aqueous solution in fraction? You must calculate it. What is the molarity of a 50 milliliter solution containing 10 grams of table sugar C12H22O11? Okay, so you must solve it again. Okay, when you grade the test, you will okay, what is the percent you must calculate it? Will be 3.38%. Molarity, the moles of solute per liter of solution we studied. This must be calculated, It's okay. After that, we finish this lesson, which is called what? This lesson, which is called solution concentration, and we studied solution concentration, molality, and mole fractions. Okay, this is enough, and we are going to complete in the other session, inshallah, with the next lesson. Goodbye, grade 11.